Okay, in this video we're going to continue on with the Unit 12 review. This video is all about solving triangles. The first one is a right triangle. If you have a right triangle, you can use Pythagorean theorem and SOHCAHTOA to find everything. Anytime you're asked to solve a triangle, that means find every angle and every side length. So I like to organize the stuff. You don't necessarily have to do this, but I like to organize all of my information in one location. I've got angle A, that's 37. Angle C is the right angle, that's 90. And I have side length B. So side length B, that's across from angle B. Side length B is 18.6. So the easiest thing to find next would be angle B. I just need to do 180 minus 90 minus 37. If I do that, that's going to give me 53 degrees here. Basically, your two acute angles should add to 90, so make sure that happens. So this is going to be 53 degrees. Then I like to find the other non-hypotenuse, right? The other leg of the triangle. So I'm going to find side length A. And you can do this a lot of different ways. So what I'm going to do here is I'm going to reference. You have to pick an angle to reference from, one of the acute angles. And I'm going to pick the angle that was given, which was 37, which means I'm looking for the opposite side length. And what I'm given is the adjacent side length. So then I've got to think, okay, well, I'm looking for opposite. I have adjacent. Opposite and adjacent, that's tangent, right? That's TOA. So that means I'm going to do the tangent of 37 is going to equal the opposite side length, which is A, over the adjacent side length, which is 18.6. And then to solve for A, I would just multiply by 18.6. So A is going to be 18.6 times the tangent of 37, which I would plug that into the calculator. Move this out of the way a little bit here. 18.6 tangent of 37, which gives me roughly 14. So A is going to be 14. And then once I had that, again, there's lots of different ways you can get this, but I think with a right triangle, to get the hypotenuse, I just prefer to use the Pythagorean theorem. So C squared is going to equal 14 squared plus 18.6 squared, and I would just take the square root of that, plug that into the calculator, and that's going to give us our hypotenuse. So square root of 14 squared plus 18.6 squared, which gives us 23.3-ish. 23.3. And now I have every angle and every side length that I'm done. So solving right triangles is something you should be familiar with because that is something you did in geometry, but that's finding every angle, finding every side length using Pythagorean theorem and using SOHCAHTOA. In this class, the new stuff is let's solve triangles that are not right triangles. I still want to find every angle, every side length. So if you want to organize this all in one location, you can do that. Write down the things that are given. B is 41, C is 53, and side length B is 23. Again, obviously, I think the first thing we would find here would be this angle A. So I'm going to do 180 minus 53 minus 41, which will give us 86. So angle A is 86. Now, the question becomes, do I do law of sines or do I do law of cosines? And again, these formulas are given. What I like to think is I want to try to do law of sines. Law of sines is able to be used as long as I have an angle and the side length across from it. I can do law of sines because we're just setting up a proportion. So since I have both parts for B, I'm going to do the sine of 41 over 23 equals, and then I'm going to go with either one of the others. It doesn't really matter. But I've got the sine of 53 over side length C. And then to solve this, you're going to do cross products. So we're going to have C times the sine of 41 equals 23 times the sine of 53. And then I want to solve for c, so I'm going to divide by the sine of 41. Plug all this into the calculator. Okay, so 23 sine of 53 divided by the sine of 41 gives us 28. So this is going to be 28. That is the answer for side length C. The mistake that some people make is they'll just say, oh, I can use the Pythagorean theorem now. That is incorrect. So I just have to set up another law of sines. So now we're just going to basically switch out the C stuff for the A stuff on this. So we're still going to use the B stuff that was given, sine of 41 over 23. But now instead of doing angle C to find side length C, I'm going to use angle A, which we have to be 86. And then I would just do the cross products and solve again. Now, what I would maybe look at is, you know, what's different? I just switched this 53 to 86. So in the calculator, since I already have that plugged in, I'm just going to switch that out and make that 86, and that's going to give me the answer. So if I go back to here and change that 53 to 86, there's my answer, be roughly 35. Okay, so side length A would be 35. But anyway, if you know the calculator shortcuts, which I talk about in this paper, this reference sheet here, where I talk about what you could plug in there to get those things, I do think that that would be helpful to kind of just know how you can quickly get those answers from those shortcuts. I'm going to skip number 14. I'm going to go down to 15 and 16. On 15, the question would be, can I use law of sines? Well, the law of sines requires me to know one of the angles and the side length across from it. And if you look at 15, I don't have any of the angles. So I cannot do law of sines. I have to do law of cosines. When you do law of cosines, you can pick whichever angle you want to start with. So we're going to look at angle A. And to find angle A, so the formula for law of cosines would be, if I'm trying to find angle A, then I would use this formula here, and I'd plug all the side lengths in and then solve for that angle. What I've shown you on this reference sheet is, if I'm using law of cosines and I'm looking for an angle, basically how to manipulate this formula here to solve for that angle. Right? So if I wanted to get this angle by itself, how would I go about doing that? Well, I would subtract b squared, I would subtract c squared, I would divide by negative 2bc, and then I would do the inverse cosine, and it would look like this. And so if I know that, it's actually really quick if I know that shortcut in the calculator, because I'm going to say, well, then angle A would be the inverse cosine of a squared, which would be 6.7 squared, minus the other 2 squared, so 17.2 squared minus 14.4 squared, all divided by negative 2 times, and again, if you just know here, this is the only one that gets used once. That's probably helpful. So 17.2 and 14.4, and again, that formula is written out there on that reference sheet. And you plug all that in, you got angle A. And then what I would probably do is, you know, whatever that gives me for angle A, I've got that. And then to find angle B, I'm going to do the exact same thing, except now I'm going to use side length B as my first value here. So that's going to be 17.2 squared. I'm essentially just switching these places. This is going to be 6.7 squared. This is going to be 14.4 squared. And then down here, I've got to remember to also replace this with the 6.7. And I've got 14.4. And then that's going to give me that answer. And then the last thing I would do to find angle C is I would just do 180 minus, you know, these two angles that I have here and here. And that's going to give me angle C. Okay, but if you know that calculator shortcut, it is literally just, you're just plugging numbers in and you're getting those things. So that would give me angles A, B, and C. On 16, I have angle A, but I don't have the side length across from it, so I can't do law of sines. And I can't get that. This is, though it may look like a right angle, I can't assume that's a right angle, so it is a non-right triangle. But I can't do law of sines, I gotta do law of cosines. I have angle A, so I'm going to use the one that deals with angle A, which is this, and now I'm just looking for side length A. So the shortcut to get side length A by itself would just be to square root that whole side. Which again, I have that on here as well. Looking for a side length, I just take the square root of all of that. So what that's going to look like is I would just do side length A would be the square root of, and it's just going to be b squared plus c squared minus 2 times b times c times the cosine of angle A, which would be 60. And that's going to give me side length A. Once I had that, then I would need to find angle B or angle C, and I would just do essentially like this to find angle B, right? Angle B would be b squared. Well, I'm going to do inverse cosine of b squared minus whatever a squared is. I would have that number from this first calculation. Minus c squared, which would be 14 squared, over negative 2 times a times 14. And again, I would have this value from whatever I got in that first part. And that would give me angle B. Once I had angle B, I could just subtract angles A and B from 180 to get angle C and so forth. Okay, so I went through that rather quickly, but you're just setting up those laws of cosines or law of sines, and you're literally just plugging things into the calculator, just making sure that you do so correctly. And knowing the shortcut for that, I would really focus in on what is the calculator shortcut, so that I can plug those things in quickly to get those answers. Real quick, I'm going to go back to number 14. If the triangle is not there, and the stuff is just written out, that is an indicator that this is the ambiguous case. So you want to look at the ambiguous case notes on law of sines. I'm going to start this with a law of sines because I've got angle A and I've got side length A. So I'm going to do sine of 44 over 30 equals sine of C over side length C. I do the cross products. I would get C times the sine of 44. Sorry, not C. That would be 32. I've got that number. I don't need to say C. This is 32. So 32 times the sine of 44 equals 30 times the sine of C. I would divide by 30. And then to get rid of my trig function, I would do inverse sine of this, right? So C is going to be the inverse sine of 32 sine of 44 over 30, and you're going to get an answer from that. Okay, so that number is going to be inverse sine of 32 sine of 44 over 30. 32 sine of 44 over 30. That number is 47.8. So that's angle C. If the stuff is written out, this is the indicator that, again, could be the ambiguous case, which means you might have an angle C2, which would be the supplementary angle to this. So if I took 180 minus 147.8, that's going to give us 132.2. This is another option for angle C as long as this plus the angle that's given, which is 44, is less than 180. So if I added 44 to that, that gives me 176.2, which is less than 180, which means this is another option for angle C. What that means is that essentially I have two different triangles now. I'm going to have two options for angle B, and I'm also going to have two options for side length B. And I'm running out of time here, but the way I would do that is I would just use angle C1 with angle A and solve that triangle first. I would essentially do all of this, and then I would just switch out that angle C for this angle C and do all of this. And that's going to give me all of the answers that I need there. If you need more clarification on that ambiguous case, please see me. I'm going to wrap this video up, right now.